right, guys. So, okay. So I think I showed you this yesterday, but it wasn't maybe done. I don't know. Whatever. I'll show it to you again. This is a summary of the test that you guys took. You can see where you guys fell in the scheme of things. Average on the test is 76. Good job, Abel. These are my A's on the test. We had no perfect scores. Highest was a 97%. So Abel, try to get that up next time, would you? That one. But good job to you guys. So think about now as we start Unit 2, new quarter. You already have one assignment that you have due, which is the progress check. That's what we worked on in class yesterday, if you remember. It's due by, what did I say? Tuesday at midnight, okay? So just get that done. That's for 10 homework points. Think about how you ended up this quarter. If you are happy with where you ended up, keep doing what you're doing. If you fell short a little bit, think about what you can change. Are you doing these things? Are you just copying the homework because I put it on Canvas? It happens. I know it does. Are you halfway listening to me do the notes and just kind of writing what I write and not taking it in? Maybe that's something you need to change. Are you not finishing homework, getting help on questions you have in the homework? Think about all those things. One of the big things I think we can take away from quarter one is how important it is that you guys are comfortable with the graphing calculators. As you saw, when it came to the calculator portion of the test, some of us kind of froze. We were like, oh, wait, I forgot where those buttons are. So maybe that's something you have to consider. Even on this most recent test, I gave you all those hints. I don't do that normally. Okay, that was just like a little gift because of the hurricane and stuff. You have to know how to use these. And that starts with in class, at home, practicing those steps. If you are constantly just watching me do stuff, you're not really learning. You guys need to pick up the calculator and execute and interact with the calculator a lot. Because after a while, just like everything else you guys do, it becomes muscle memory. You'll start remembering where everything is the more you use this stuff. Like, for example, the questions that we had where you had to do like stat, enter. You have to turn the calculator on first, apparently. Stat, enter, and like you put your X's and Y's in. All of that stuff, the stat calc, turning your stat plots on, using the table, using intersect, all that stuff is coming up again in Unit 2 and again in Unit 3. So you'll be interacting with your calculators the same way as you were before. So it's really important if you think about what you need to do to either continue being successful or to up your game a little bit, okay? Don't forget SAT and PSAT are on Tuesday, so if you have the desire to get your own graphing calculator that you can use for the SAT, remember I told you guys this yesterday, but I just want to reiterate, you can't come to me the morning of the SAT and say, can I borrow one of your calculators? Because I'm going to want to say yes, but I'm not allowed to because I don't have enough for everyone. I can't just give it out. But if you want to check one out, it's super, super easy. Go on Canvas. There's an announcement with the link in there. You fill it out, and then you go see Miss Amio Prizo in the Media Center, and she will check that you did your little online thing, and she'll hand you one. It's very, very simple, okay? You're not required to have one at home, but it is nice if you're doing homework at home to have one of these. But the reason I'm bringing this up urgently now is because the SAT is coming up, and you can use these on the SAT or PSAT. So if you want to check one out, I would do it today or Monday. Don't wait till Tuesday because it'll be too late because she'll be busy. I'm sorry? Yeah, Tuesday's the day you're doing the PSAT or SAT, whatever. Okay, does everybody understand all that I understand? Yeah. Okay, Unit 2, first day. I think you guys are going to find, I think the feedback today was this is pretty simple. You may even remember some of this from Algebra 2. We are talking about sequences, and sequences are like an ordered set of numbers in math. But like in the real world, you could say like a sequence of events. It's like what happened first, what happened second, what happened third. In math, a sequence is a pattern of numbers, okay? And like a really easy one, a common one that we all know is like even numbers. You can count by 2s, 2, 4, 6, 8, and then it keeps going. Those 3 dots are called ellipses or ellipses, I forget. But it just means, and it continues, all right, keeps going on and on. And what that means is it's an infinite sequence. If it keeps going, infinite, infinity. It just keeps going forever and ever. There's no end to it, okay? Versus a finite sequence, finite. A lot of students will say finite, which is not proper, but who cares, okay? As long as you know what that means, a finite sequence means it has an end. Like if we talk about the months of a year, the first month is January, the second month is February, and so on until you get to the 12th month, which is December. And it doesn't go any further, right? So from January to December is a finite sequence. It has an end. The months don't just keep on going into, it just repeats itself, right? All right. And so that's the difference between infinite and finite. Nth term, and I'll tell you, this whole lesson is more about understanding like the notation and how to work with a formula and how to write a formula than doing the math. The math part of this is really easy. And it starts with this nth thing. The nth term is the general term, and the letter K is used. I'll explain this much better with an example in a second. But just to give you an idea of where we're heading with this, what we would do is, this is called the first term. And you would write it as a sub, I'm saying S-U-B, sub 1. This is the second term. We'd call it a sub 2, and so on. This would be your fourth term. And there's a 50th term, and a 500th term, and a millionth term, right? I'm saying sub because it's a subscript. So a sub 1. That's your nth term, the second term, the fourth term. That's what they mean when they say nth, okay? And there's something else I want you to write here. We're going to talk a lot about something called an explicit formula, or it's also called the general formula. An explicit or a general formula is a formula, go figure, used to find the nth term. So you'll be given a formula, or sometimes we're going to write our own formula, and it'll say use the explicit formula or use the general formula to find the 50th term, the 100th term. It's a way of jumping ahead in line. In other words, back to our counting by even numbers, 2, 4, 6, 8, we could easily come up with the rest of this, right? All of us could sit here and go 10, 12, 14, and we get to a point maybe we have to get our calculator out, I don't know, whatever. But what if I said to you, I want the 768th term? You wouldn't want to sit here and do this up 668 times or whatever I said. There's a formula called an explicit formula that you could create given the first few numbers, and then you can jump ahead in line and just go straight to whatever term you want. Okay, so we're going to talk about all that now. So here in example 1, it says there's a sequence that has an explicit formula. Okay, it's given to us right here. Here's a formula that we can use to find the nth term. It's telling us to find a sub 12. Notice there's one variable in this whole example here, and it's n. And n would be, what do you think? 12. Yeah. So we're going to go ahead and plug 12 in wherever we see an n. And then you can do the work in, you can do the work in your calculator. You don't have to write out all the steps. A lot of this is not showing work using a calculator. 12 times 12 is 144, and 144 plus 3 is 147. So the 12th term represented by this explicit formula would be 147. We jumped ahead in line. We just went straight to the 12th one. We didn't have to start with the first one and then the second one and the third one. Okay? All right, example 2, write the first 4 terms of each sequence. Okay? So I'm going to find the first, the second, the third, and the fourth term, the first 4 terms, simply by plugging in 1, 2, 3, 4 in the formula. Now, I'm showing a lot of work here in the notes. When you get to the homework, you do not have to write all this out. You could be doing this in your head or in your calculator, whichever you need to do or want to do. Okay? Yep.
For these ones, if you plug that equation into like a graph and go on the table, does that work?
Yes, it would work. I never even thought about that. Good, Daniel. Yeah. And let's just, and I know this isn't what you're saying, let me piggyback on what you just asked. Could you type this in your calculator and go to the table? Sure, absolutely. You put it in y sub 1, go to your table, you would get any number you needed. But when won't that work? if it's a non-calculator question. Because remember, this test, they're sneaky. We split things into some questions are calculator, some are not, because there are certain things we think you should know how to do without a calculator. So we want to know both ways. But yes, absolutely good question. All right, so 3 minus 4, 6 minus 4, 9 minus 4, 12 minus 4. Those are the first 4 terms. So you might see it written like that. These are your first 4 terms of a sequence. A sub 1, A sub 2, A sub 3, and A sub 4. Okay? Same thing here. Let's find the first 4 terms by plugging in 1 through 4 in the equation and then doing the math. What, Michelle? I would just stay with me. But yes, we are going to do example 3. But there might be something worthwhile that I'm going to say about it, so stay with me. Okay, don't forget, when you do a negative number to a power, if it's even, you're going to get a positive answer. If it's odd, you're going to get a negative answer. So negative 1 to the first power is negative 1 plus 5 is 4. Negative 1 to the second power is positive 1 plus 5 is 6. We'll get negative 1 plus 5 is 4. Positive 1 plus 5 is 6. So 4, 6, 4, 6. You can probably predict what the next 2 numbers would be. 4, 6, 4, 6. Okay? All right. Any questions? Stop me if you do. Example 3, another. So what you'll see me write in my notes a lot is EF. That's explicit formula. They're giving us an explicit formula. I want you to know those words. Or a lot of times you'll see explicit formula or general formula. I usually use explicit, okay? So I'm just saying when I write that, that's your formula. You can find the first 3 terms, the 11th term, any term. So first 3 terms, the 11th term. That's what we're trying to do here, okay? And the only thing I would warn you about with any of these problems, the only mistakes I've seen all day really have to do with order of operations. Guys, order of operations is always in effect, okay? You go into any English class, or let me just say any class, and you have to read a sentence. You read the sentence the same way no matter what class it is, okay? In math, we don't always work a problem out left to right. And some of us want to just, we love our calculators, and we love letting our calculators do the work. And they do a lot for us, and I love my calculator too. But remember, sometimes if you just type something in your calculator left to right, it's not necessarily going to give you the right answer. You should always take control of order of operations. And don't forget, you don't solve this left to right. It's not 4 plus 1. It's parentheses, then multiplication, then add. So 1 minus 1 is 0, 0 times 5 is 0, and 0 plus 4 is 4, and so on. 2 minus 1 is 1, 1 times 5 is 5, 5 plus 4 is 9, right? 3 minus 1 is 2, 2 times 5 is 10, 10 plus 5 is 14. So there's the first 3 terms. And you could keep going, right? You could find the 4th, the 5th, the 6th, the 7th, the 8th, the 9th, the 10th, and then you'd get to the 11th. Or remember what the explicit formula is good for. Jump ahead in line. I don't care about term 4 through 10. I want just term 11. So that's what these are good for. I can just put in whatever term I want, which is the 11th. 10 times 5 is 50, plus 4 is 54. Okay? Good? So we just talked about what a sequence is. It has a pattern. Okay, you could predict the next number if you know the pattern. There's a specific type of sequence called an arithmetic, and it is pronounced like that, even though sorry, I thought you were sleeping. Even though it's spelled like arithmetic, and it's okay. We don't get hung up on all that stuff in this class. Spelling doesn't matter, punctuation, pronunciation, but of course I'm going to say it correctly. Arithmetic. Okay, that's how you say it. And an arithmetic sequence is very specific and very simple. In an arithmetic sequence, you're adding the same number left to right. You're not taking the square root, subtracting 8, and then squaring it to each number. Like that, as long as there's a pattern, it's a sequence. But arithmetic, just like our old friend here, the even numbers, 2, 4, 6, 8, that would be considered an arithmetic sequence. It has something called a common difference. A common difference is represented by the letter D, and D is the number we are adding as we go left to right. What are we adding as we go left to right in this problem? Right? Positive 2, positive 2, positive 2. So our D would be 2 in this. And we could use that and find the next one and the next one, right? Plus 2, plus 2, plus 2, plus 2. Can a D be negative? Yeah, of course. Look at this sequence. What am I adding as I go left to right? I'm adding negative 2. Does it end up being subtraction? Yeah, but what am I doing left to right? I'm adding a negative 2. Why is that so important? Here's the reason. We used mental math to find the D for both of these, but what if we had like really yucky fractions or decimals, or we couldn't tell just by looking at it what the pattern was? What are we adding? So what you can do is, and you don't have to write it out, I'll show you when we get to an example, is you can test it. But remember, to test something, we go in the opposite direction. So if I can't tell, I can't tell what I'm adding here, what I could do is any two consecutive numbers, meaning right next to each other, in reverse. So see how I'm subtracting in the opposite order? 4 minus 2, 6 minus 4, 8 minus 6. In all of these situations, I get 2. So that means that's what I'm adding when I go left to right. Look, 6 minus 8, that's my D, negative 2. And I'll show you that again when we get to an example. Okay, and that's all this is saying. To find the D, you're subtracting the second term minus the first term, and then the third term minus the second term, and so on. Okay, specific to arithmetic sequences, it has its own jump ahead and line formula. And it looks really crazy here. Focus in on these two right here. And I'm going to show you with an example because it's way more complicated if I just try to describe all this stuff to you without an example. But these two are the same exact formula, just simplified. Okay? So we always start with this formula. You're going to see me do it right now in a second. And then when you simplify it, it'll look like this. And I'm going to show you that right here. Okay, and Monday we'll take the time to take out our formula sheet and write these formulas. But right now, just keep looking up here. This is where I'm going, okay? So let's look at our first example. Example 4, is the sequence an arithmetic sequence? So we're going to see, are we adding the same number left to right? That'll be the first thing. So yes or no. And then if it is, we will write a general rule. This means the explicit formula, okay? That formula, okay? So do we have a D in this problem? Are we getting the same number as we go left to right? Yeah, what is it? 4, right? We're adding 4. If you couldn't see it, you would do 5 minus 1, 4, 9 minus 5, 4, 13 minus 9, 4, and so on. D is 4. All right?
Oh, wait, no, is that D? Okay.
D. This?
Yeah.
Sorry, D. Sorry. I confused you. Okay, so is it an arithmetic sequence? Yes, it is. Okay, if so, write a general rule. So first thing I want you to notice is the A sub n. This is important. Anytime you are creating an explicit formula, you leave the n, what I call empty or blank. I can't think of a good word for that, sorry. And here's what I mean. Don't put anything in for n. Don't put anything in there. A sub n equals A sub k. Now listen, this is important. I'm going to show it to you two ways. You can put any term you want. You can put a 1 in there, a 5, a 9, you can put any of them, okay? I'm going to be boring and just put in A sub 1, which is the first term, which is 1, happens to be 1, okay? Just stay with me on that, and I'm going to come back to that. Plus the D value, which is 4. Leave n empty or blank. Anywhere you see an n, we don't put anything in there. And then this number that comes next is k. So remember we did A sub k? Here, I used 1. What do you think k would be? 1. It's the first term, right? A sub 1, k is 1. We'll come back to that in a minute. So that's the explicit formula, but you never leave it like that. We have to... Yeah, of course. Sorry. Stay on me if I do that again. Don't let me keep doing that. So we never just leave it like that. We want to simplify it. When we simplify it, it's just going to be written in this form. To simplify, we just distribute. So that's 4n minus 4. And then we can combine like terms. So a sub n equals 4n minus 3, or you could write negative 3 plus 4n. Either way, doesn't matter. This is my explicit formula. Both of them are, okay? This is just simplified. Okay, let me show you what I just simplified this to. Remember I said they're the same thing? D times n, well remember D was 4, so there's the 4n, and this negative 3 is a sub 0. Well, think about it. If this is a sub 1, a sub 0 would be the number that comes before it. So I would subtract 4. So it would have been negative 3. So a sub 0 is negative 3. It's right there. It's created naturally when you distribute. You don't really have to think about it. But just understand, these two are the same thing. It's just one is more simplified than the other. This is the form you want it in. This is the better of the two. So anytime we have to come up with an explicit formula, we plug into this one and we just simplify it. Okay? And so that is the answer right there. That's the general rule or explicit formula. Now remember I said I was going to come back to it. I want to show you another way you could have written this. Remember I said I chose a sub 1. I'm boring. I always choose the first one. But you could choose any of them. For example, what if I chose 9? I want to use 9. I like 9. Okay? So I'm just plugging right into this formula. So I chose the third term, right? A sub 3 is 9. So I chose that. I'm just plugging right into the formula. D is 4. N is always left empty. What would I put as this number right here?
9. Oh, no, yeah,
3. Because that's the K. A sub K, that's my third term. So whatever number you put here, it doesn't matter. Now it looks like a different answer, right? What I have written in blue and purple are different. But look what happens when I simplify it, which we're always going to do anyway. If I simplify this, I would get 4n minus 3. So it does not matter which term you use, okay? If you want to match my work, I'm boring and I always pick the first one, so k is 1. But I just proved to you that it doesn't matter. So if I had put a 5 here, this number would have been a what? If this was 5, look at my pen, guys. If this is 5, what would this be? 2. Okay, you get the idea? But it will simplify down to the same answer. All right, here's another sequence. Find the 46th term. That's what we're being asked to find, a sub 46. We don't know what it is. They want us to find it. You always start with a D. We need the D first. So what is our D here, guys? 3, right? So you could keep adding 3 if you want to, so you get to the 46th one, or let's make an explicit formula. So we're just going to plug right into here. So a sub n, always leave n empty. Again, I like to just use the first number I see, 2. D is 3, leave n empty. And since 2 is my first term, what number goes right here? 1. Right? And you could have chosen any number because once you simplify this, we would get the same answer in the end anyway. Okay? Here's our explicit formula. In the last problem, it didn't ask for it. It just wanted the explicit formula, right? And so we were done. This one didn't even ask for the explicit formula. It just said, what's the 46th term? Well, the first step is getting a formula, and then we can plug 46 in, and we can just put it in our calculator. 3 times 46 minus 1 will get you 100. How was that? Did we do okay with that one? 2 more examples. It's all the same stuff, just worded differently, okay? Find the 9th term. Find the 9th term. That's what we're trying to find. So we're trying to find a sub 9. That's what we don't know. What did they give us? Okay, they gave us in an arithmetic sequence, the first term is 8. Okay, let's write that in mathematical code, right? First term is 8 and has a common difference of -5. That means D is -5. So we need the 9th term. Could I just subtract 5 from this 9 times? Yes, but we're going to make an explicit formula. So we start by a sub n equals. They gave us the first term, which is 8. A sub 1 will be 8 plus -5 parentheses n, remember, never plug anything in for n, minus, and this was my first term, so that's why I'm going to put a 1 here. If they'd given me the third term, I'd put a 3 there. Depends. Go ahead and distribute. Remember, a negative times a negative is positive. And you can write -5n plus 13 or 13 minus 5n. There's your explicit formula. Okay, now, what do you want me to find? 9th term, no big deal. All I have to do is plug 9 in for n and pick up my calculator. 13 minus 45 is -32. We doing okay? We have one last example. Example 8 on the next page. Word problem. The word problems are typically not scary word problems. You'll see what I mean. Yep. On what problem? Where is K3? Are you talking about up here? Because when I did this example, 9 was the third term, right? First term, second term, third term. So if I'm going to use a sub k as 9, k is 3. It's the third term. If I use the first term, k is 1. Whatever what? Whatever term number it is, that's the k value, okay? Okay, they love, whoever they are, love to do word problems in this chapter that have to do with like sports arenas or theaters or movie theaters, things like that. So the number of seats in the first 16 rows of an arena form an arithmetic sequence. So there's 16 rows, okay? And it tells us there are 20 seats in row 1. So that would mean in A sub 1, we have 20 seats. In row 2, which would be the second number, we have 23 seats. How many seats are in row 16? So that's what we're trying to find. So we're going to start by making an explicit formula. We need the D. If we have the first term and the second term, we can easily find the D, which would be 3. Okay? So now, I'm going to write here, just to help if anyone's lost. I'm writing the formula again. D n minus K. Okay, so that's the formula that's on the other paper. So I'm going to leave n blank. Remember, don't put anything in for your n's. Now, Christian, I can use 20 or 23. It doesn't matter which one I use. Like I said, I'm boring and just use the first one. D is 3. Leave n blank. So, Christian, since this is the first term, K is 1. If I had used 23 right here, Christian, this number would have been a 2. Okay? It doesn't matter. You get the same answer either way. So I would get 3n minus 3. So there's my explicit or general formula. Either way you want to call it. Okay, now what do you want to know? Oh, 16. Okay, no problem. I'm just going to plug 16 in for n and put that in my calculator, and I would get 65 seats in the 16th row. And be smart. Look at your final answer. How many times have you had math teachers say, does your answer make sense? Like if you accidentally got a negative number here or like a number less than 23, it wouldn't make sense. You made a mistake in your math. It should be getting bigger. By the 16th row, it should be more than 23. We can't have a negative number of seats. Okay? Good? That's it. Homework. You will notice now we're in quarter 2. I call my assignments B. Instead of A, 1 through whatever, we do B. Quarter 3 will be called C. Quarter 4, D. Now, I decided to be nice and I cut number 20 and 21. I made them optional just to kind of give you a break on the Friday. They're lovely problems. I originally assigned them. I did put the key on Canvas, so if you want to try them, this is like that first step of what kind of math student am I going to be this quarter? Did I understand 17 and 18, the other word problems okay? Great. Maybe I don't need to do those. Or maybe I'll save them for a day I need to practice. Or, you know what? I'm not getting this. Maybe I should do 20 and 21. But bottom line is, if I check the homework, this as a homework check, 20 and 21 are optional. Okay? So let's get started. I'm going to get started with you, Tathan. Come on. No sleeping. It's so tantalizing, exciting. How could anybody sleep during that lesson? Crazy. Okay, 1 through 4. Very simply, yes or no, is it a sequence? Is it an arithmetic sequence? If it is, what is the D? Okay? So sometimes you can just look at it and tell, right? So this is a sequence. It has a pattern. I'm adding 0, I'm adding 1, I'm adding 2, I'm adding 3, I'm adding 4. I can predict what the next numbers are. But that's not specifically an arithmetic sequence, right? So this is not an arithmetic sequence. I'm adding a different number every time. It has to be the same, okay? Number 2 is a great example of that's not something I can do mental math so easily. So, and you don't have to write this, but how I would test this is I would pick up my calculator, and I'm going to write here what I'm typing in my calculator so you can see. Remember, to test it, you go in reverse. So it's negative 74 minus negative 83. And negative 65 minus negative 74. And so on. And you want to make sure, am I getting the same number every time? You do not need to write this out. You can just pick up your calculator. And of course, instead of doing minus and negative, you could do plus. Negative 74 plus 83. Oh, I get 9. Negative 65 plus 74. I get 9. I get 9. So yes, D is 9. And I just want to do one more so we can remind ourselves how to do fractions in our calculator. When you put a fraction in your calculator, you use your division button, and you have to put it in parentheses. Well, let's type this in. So parentheses, 5 halves minus 1, right? Must put it in parentheses. And you can leave it just like that. I'm sorry, minus 4. That's a 4, sorry. 5 halves minus 4 would be negative 1.5. You can leave it like that, Kaylin, or you can hit math, enter, enter, and write it as negative 3 halves. Either one, it doesn't matter. But you will get the same answer the whole way down. And you can leave it as a decimal or write it as a fraction. Okay? I will put the key up. I'm available for help. Everyone should be working. The key is online as well.